Okay, so now in this chapter, we're going to start getting into the real chemistry. We're going to start talking about how you name chemical compounds. Why is salt called sodium chloride? Why is carbon dioxide called carbon dioxide? And so we're going to talk about that, and we're going to talk about how to write formulas for them as well. So this is kind of one of those foundational things that you guys really have to be very, very good at by the time it's all said and done. So the chemical names and formulas that we use nowadays, they didn't really exist until recently. They used to use just kind of weird names for things all the time, based on where they found them, what color they were, what they were used for, things like that. And so blue vitriol, I'm not even sure what that is, something copper, I'm sure. Gypsum is calcium carbonate or calcium oxide. Laughing gas is dinitrogen monoxide. Milk of magnesia, they call it that because it was made out of magnesium carbonate, I think, and you put it in water and it looks like cloudy. And then sugar of lead is lead acetate. And so they had all these just weird names. You just basically had to memorize everything, what everything was, okay? And that's intense. So what they did is they came up with a system for naming compounds based on the elements, what kind there are, and how many there are present in each compound. So there's 3 different kinds, and we're going to talk only about inorganic. Organic compounds is a whole nother several years of college chemistry. It's very in-depth because there's millions of organic compounds. The inorganic compounds are far fewer, and so they're one of 3 types. So type 1 compounds are binary. That means they have only 2 elements. That means 2 capital letters. That's what you're looking for. Okay? And they are created when a metal atom and a non-metal atom trade electrons. What that does is it creates a cation, which is a positively charged ion, and it creates an anion, which is negatively charged, and opposites attract. That's where you get these compounds. They're called ionic compounds. And the rule is that the amount of electrons that are lost by one element has to equal the amount of electrons gained by the other ones. And I'm going to show you a little trick for that. Basically, we're going to do something called drop and swap. So in binary ionic compounds, the way it's written is the metal part, the cation, is always written before the anion. So it's usually metal, sorry, bad handwriting, and then non-metal, in that order. Okay. The numbers of atoms of each element are indicated by subscripts. That would be numbers written down low. There aren't any here, so you can assume it's 1. And they are written to the right of the letters of the element. So for example, CO2 means 2 oxygens, only 1 carbon, because it's understood to be there. Okay, so AlCl3 means 3 Cls, 1 Al. Okay, so when you name them, the way you name them is you name the cation first, and that would be just whatever the name of the element is. Okay, so sodium chloride, for example. Then you name the anion by taking the name of the element and dropping the suffix, dropping the ending, and you're going to add IDE to the end. This is the systematic method. Okay, so AlCl3 is aluminum, because that's the name of Al, and then instead of chlorine, we drop that ending and we add IDE, so chloride. Or Mg is magnesium, oxygen. Oh, I forgot the X. That's what's missing. Drop the ending and add IDE. Okay, so magnesium oxide. That's where we get these names. They always end in IDE. K is potassium, full name. Instead of sulfur, drop the ending, add IDE, sulfide. Rb is rubidium. N is nitrogen. Drop the ending and add IDE. Notice one thing in particular. None of these names talk anything about how many of each there are. I gave you examples where it's 1 and 1, 1 and 3, 2 and 1, 3 and 1. It doesn't have anything to do with how many there are. All it has to do with is the elements that are in there. So, naming the following compounds. So I want you to go ahead, write these down in your notes, and come up with the correct names. Okay, remember you're going to drop the ending, and it's something you just kind of have to get used to, what the ending part is you're getting rid of, and add IDE. So I'll have you pause the movie, go ahead and do this one, and then I'll go over the answers. All right, so for the first one, Na is sodium, and then fluorine is Fluor, and then you drop the INE, and you're going to add IDE. Okay, one thing I want to point out, this is Mrs. Packard's particular pet peeve. I hate it when people spell fluoride wrong. It's the only thing I'm ever going to grade you guys on spelling. So the correct way to spell it is Fluor, not this. You are not baking a cake. It's fluoride. Fluoride. It's one of my pet peeves. My students are going to have to worry about that. I don't know about Miss Ellis and Mr. Lindenberger, but that is my particular pet peeve. Okay, next one, calcium. And then bromine, drop the INE, and it becomes bromide. Again, IDE ending every time. Aluminum. And then this one's weird. Iodine, you drop the INE, add IDE. So iodide, you may have heard that about. That's a potassium iodide is an alternative form of salt. So, lithium, oxygen becomes ox, IDE. Strontium, sulfur becomes sulfide. CS is cesium. Nitrogen becomes nitride. And then the last one is magnesium. Phosphorus is kind of a weird one. It's phosphide. Okay, just something you have to get used to. As long as you have it ending in IDE, I'm not too worried about it because I realize that this takes some time to get familiar with it. So, all right, formula writing, though, is a little bit different. In formula writing, you need to know the common charges of each element. Now, we did that as part of your periodic table. In the last chapter, we talked about the common charges that each ion get. Metals are always positive, and nonmetals are always negative. And these are, again, binary ionic compounds. Okay? They are always negative. These are always positive as long as it's the two of them together. And each family in the periodic follows a common pattern. You should have them written there, but I'm just going to run through them real quick. Maybe not. The rule is the total charge in the compound has to equal 0. That means you have to have the sum of all the positives canceled out by the sum of all the negatives. And what we're going to do instead is we're going to do something called drop and swap. Identify the element and its common charges. So calcium is Ca. Iodide comes from I, and I want you to write the charges down up here as superscripts, just like when we did when we were doing isotopes. You don't need to know the masses and stuff. All you need are the charges and the symbols. One capital letter for each element. Okay? And then what you're going to do is you're going to do this thing called drop and swap. What that means is you're going to take the number from the metal, and you are going to drop it down and swap it over here by the I. And you are going to take the number by the I, and you are going to drop it down and swap it over by the calcium. Okay, not the charges, just the numbers. That's important. Okay, so that one, the 1 moves over there, and the 2 moves over there, and what you end up with is Ca1, I2, or just CaI2. And the reason this works is, remember, calcium had a positive 2 charge. And I've got iodines. Each one of them are -1, but if I have 2 of them, the total charge on this is positive 2 from the calcium added to 2 times -1 for the iodine ends up 0. That's what this is all about. Okay? The reason it works is because the charges add to 0. The sum of all the positives and the sum of all the negatives add to 0. Okay? You don't include the numbers. What this is, or the numbers. The positive and the negative. That tells me I only have 1 calcium and I have 2 iodines. That's what it tells me. You don't include the charges when you do the drop and swap. So go ahead, look up the formulas. Okay? Drop and swap. And here's the other thing that I didn't talk about. If it's at all possible to simplify or reduce, that's something you want to do with these. Okay? So I'm going to give you guys a second. Copy these down. Go ahead, look it up on your periodic table. Practice them, and I'll put up the answers in a second. All right, so aluminum fluoride, Al, positive 3, Fluoride, -1. If I drop and swap, the 3 moves down here, the 1 moves down here. I get AlF3. You don't have to show the 1 if you don't want to. Sodium sulfide, Na, 1 plus, S, 2 minus. The 1 drops, the 2 drops and swaps, both of them. You get Na2S. Potassium phosphide, K, 1 plus, phosphorus, -3. Drop the 1, drop the 3, swap them both, and you get K3P. And again, you don't have to show the ones if you don't want. Now this one's an interesting one. Calcium, +2, oxygen, -2. So I'm going to take the 2 and the 2 and I'm going to drop them and swap them, and I get Ca2O2. And so this is where that last little rule, simplify it all possible. If you can reduce this 2 to 2, you can reduce it to 1 to 1. And that's the way you would write it. This would be the acceptable answer, not that. Gallium nitride is Ga, +3, nitrogen, -3. Again, drop and swap. You get Ga3N3. And again, if you can simplify, simplify. Okay, last one is Al, 3 plus, Se, 2 minus. Drop and swap the numbers. Al2, Se3. And you're done. So these aren't too bad. Okay, you have to remember the drop and swap, and you have to remember to simplify. It's not too bad. Don't take the positive and the negatives with it. It's not too hard.